Let's study the methods for determining the focal length of convex lens. Here, we'll be studying two methods for determining the focal length. First is the method of distant object method. Now, the principle in this context is that a beam of parallel rays from a distant object incident on a convex lens get converged in the focal plane of the lens. You're well aware of it that whenever the object is at infinity, the image is formed at the focus. That means the distance between the image and the lens will be the focal length. So here you can see that a convex lens is placed, right? This is a convex lens, which is, uh, the light from this distant object, a tree is passing through the lens. It is going and converged, and we can see a inverted image of the tree being obtained on the screen. So keeping in mind that when light rays from infinity pass through the lens, they converge at the focus. So that means the distance between the convex lens and the screen, this distance will be the focal length. So this is the focal length. Over here it is indicating 40 centimeter and 10 centimeter. That means the focal length will be 40 minus 10, 30 centimeters. So this convex lens has the focal length of 30 centimeter. So that means this method was simply based on the fact that whenever the object is at infinity, the image is formed at the focus. So distance between the lens and the screen will be the focal length. Second method to determine the focal length is known as auxiliary plane mirror method. Now here you can see the setup that is used. Here you can see that there is a stand on which there is a pin fixed. Over here, this is a mirror strip on which we have a convex lens. And the image of this pin is seen by the eye. Can you see the position of the eye? When you look below, then you will see the image of this pin, and we need to remove the parallax. We will get the image at this place. Then the distance between the image and the optical center is obviously going to be the focal length. So in general, at times we say that the distance between the pin and the mirror is taken as y, and the distance between the pin and the top of the lens is taken as x, and then when we determine the focal length, we take the mean of the two readings. Now why do we say that this distance between the image pin and the lens is the focal length? Let's find out. Now see, this is a view which is giving you, with some distance between the mirror and the lens. This is done only for understanding, and the practical can be done in this manner also. Now see, this is an object. Now what will happen? Let's say the light from this object is falling in this way, okay, on the lens. Now this light, after getting refracted, becomes parallel. Now why it will become parallel? It will become parallel only when the object is at the focus of the lens, right? So when the object is at the focus of the lens, then the light beam which falls on the lens after refraction will become parallel. Now since this is parallel, it will fall normally on the mirror. It falls normally on the mirror, so you know a light ray which falls normally on the mirror retraces its path. That means this light ray will be reflected back as it came in the same direction. Now when it gets reflected back in the same direction, this becomes a parallel beam of light which is falling on the lens. Now you all know that when a parallel beam of light falls on the lens, all the rays go and converge at the focus. That is why when you keep an object over here, the image is obtained at the same place. And this distance between the optical center and the pin becomes the focal length. So these are the two methods to determine the focal length of a convex lens. First was distance object method and second was the auxiliary plane mirror method.